All right, welcome back, geometry. And today, like I said, we're going to talk about regular polygons again. But today we're going to talk about it in terms of sometimes you having to use a little bit of trigonometry with them. So what I decided to do is just do that on paper. I think sometimes it's a little bit cleaner to see, especially with some of these extra steps. So one of the things that we're going to look at here is that I'm going to say that we have for example, a hexagon. So when we have a hexagon, and you'll have to forgive me here, my drawing isn't all that great. If it's a regular polygon, a hexagon has 6 sides. And we know that all 6 of those sides are the same. We also know that all of their angles are the same as well. Now, one of the things I want you guys to get in the habit of doing is just, no matter what shape we have, or what we work with, I need you guys to remember that somewhere along the lines, there will always be 3 sides that connect. In the middle of this will always be an apothem that's perpendicular to a side, and it bisects it. So whenever we deal with any one of these problems, I never want you to draw the figure. I want you to draw this diagram right here, okay? And then I want to add this little piece, because this is an exterior angle, okay? When we're dealing with exterior angles, oh, sorry, I didn't mean to hit you that hard, but can you please be quiet? Sorry, my child is playing Fortnite and it's loud. Did I get you there, Connor? Yeah? Knock some. I didn't cut your head. No, I didn't. Anyway, so what we want to do here is remember how to find an exterior angle. We would always take 360 degrees and divide it by the number of sides. So a hexagon has 6 sides. So we take 360 divided by 6, and that would give us our exterior angle of 60 degrees. So, if it's 60 degrees there, that means the supplement to it is 120. Now, here's the really interesting thing that happens with when we're dealing with regular polygons. From the center, when it's drawn to the angle here, the vertex, it actually cuts this angle into 2 congruent sections. It's also a bisector. So if the whole thing was 120, that meant that this guy is 60. That didn't show up very well. Let me zoom in just a little bit here. There we go. So you get 60 degrees on the inside. Now, I didn't say that we had any side lengths. So let's just make this really easy on ourselves. We'll say our side lengths are 10. So that means this whole side is 10. And if these 2 guys have been bisected because of the apothem, that means each one of these are 5. So what we're going to wind up doing here is we're always going to do the same thing over and over again. Here, we're trying to figure out what our apothem is. I want you to notice, we know our angle here is 60. The apothem is opposite it. The 5 in the right triangle here is the adjacent. Now, if you remember, what trig function is opposite adjacent? That's right, tangent. So what we're going to wind up doing is we're going to take the tangent of whatever this angle is, in this case it's 60, is our opposite, our apothem, over 5. Now that means we just have to multiply up by 5, tangent of 60, to figure out what our apothem is. Take out our calculator again. Make sure we're in degree mode. We are. So we have 5 tangent 60, and I get my apothem at 5 root 3. So that's how we figure out our apothem. We also know that the formula was 1/2 perimeter apothem for the area of the regular polygon. So our perimeter, well, the hexagon, as you recall, 1, 2, 3, 4, 5, 6 sides of 10, which means the perimeter is 60. Our apothem, we found using trig over here, was 5 root 3. Now we should put it all together. 1/2 the perimeter, 60, times the 5 root 3. Go back to our calculator. 1/2. Oops, so you can see this. 60, 5 square root 3. And hit enter. Sometimes it'll give us an answer with the square root in there, sometimes it won't. In this case, it did not. So whenever you do that, we always go to 2 places. So I look at the 7 and makes this a 1. So our area is going to equal 259.81 units squared. Okay? Let's try one more like that. This time, let's say that we have an octagon. If you remember, an octagon has 8 sides. And we'll say that each side equals 6. I'm not going to draw it because we all know that I can't draw, but I do know that somewhere along the lines there's going to be 3 sides that are connected, just like this. The apothem is in the middle. It's the perpendicular bisector of a side. This goes and bisects the angle, and we have an exterior angle here. So far, so good. So, side length is 6. The bisected part goes here and here. So right now, we know that our perimeter is going to be 8 sides of 6, which is 48. We have to figure out our apothem part. Well, remember, what we did earlier, we're going to do the same thing. We're first going to figure out what the exterior angle is. So the exterior angle is 360 divided by the number of sides, which is 8. So, in your calculator, 360 divided by 8, you're going to get 45. So the outside angle is 45, which means the whole inside angle is 180. Subtract that, is 135. Remember, this radius piece here bisected that, so we divide that in 2. And our interior angle that we're going to work with is 67.5. Our apothem, again, is our opposite. Our 3 is our adjacent. And lo and behold, we're using tangent one more time. Basically, we're going to use tangent over and over again. So we have tangent of our angle, 67.5, is the apothem over 3. Multiply the other side by 3. And this will give us our apothem. So go back to our calculator. 3 tangent 67.5. Hit enter. And I get our apothem, always go to 2 places, of 7.24. And I rewrite it down. So from here, we know that our area of the regular polygon is 1/2 the perimeter times the apothem. Well, our perimeter, we already found that out, was 48. And our apothem was 7.24. Calculator. 1/2 times 48 times 7.24. Oops, I hit divide by, sorry. Change that. And I get 173.76 something squared. Okay. Remember, I cannot stress the importance enough for every one of these times you draw a 3-sided figure, apothem down, perpendicular bisector, mark, mark. You're going to draw this figure every time. The exterior angle is 360 divided by n. That goes here. This whole thing is the supplement, and then this part is the half of the supplement. Here's your apothem. You're going to use tangent because this is your opposite, and this is your adjacent. Okay. I have on the formative site, I think I've got 4 of these for you guys to try using the trig as well, and you should be okay. So give them a shot. Remember, shoot me an email if you have any questions, because if you post a question on formative, it's not showing up all the time, or that I don't get notification unless I'm on the actual website. So you'll have to shoot me an email to let me know that you did that, okay? So good luck, and we'll talk to you guys tomorrow. Thanks.